Okay, so this is section 4.3 of sports stats. We're going to talk about measuring center. And when we talk about that, we're talking about mean and we're talking about median. Now, the mean, okay, the mean is the arithmetic average. In other words, what do you do to find the mean? You take all the terms, add them up, and divide by the number of terms. Okay. Now, to find the mean, they tell us that here, and then on a histogram or dot plot, the mean can be estimated by locating the balancing point of the distribution. We'll talk more about that in a second. Okay. Now, the mean is also affected by all values. Okay. It's affected by all values. So any big number or small number could drastically affect the mean. Okay, that's why average. If you're a running back and you average 140 yards a game, and you have a game where you rush for 47 yards, your average is going to go way down. Okay, all values can affect the mean. Now the median. The median. Is the middle value when the values are in order from smallest to largest. So the median only looks at values positions, not how high or low they are, just where they're at on the list. Okay? If there are two middle values, then the median is the average of those two middle values. So in general, and by the way, capital M will be the median, so we'll use that notation, and then X bar will be the mean. That's what this says. This is X bar. Okay. In general, when distributions are skewed to the right, the mean will be greater than the median. So skewed to the right, the mean will be greater than the median. This means that more than half of the values will be below average. Likewise, in distributions that are skewed to the left, which are fairly rare in sports, the mean will typically be smaller than the median. Okay, so remember you're skewed right. Okay, looks like this. Skewed right. Okay. Your median's going to somewhere be in there, okay, and your mean will be right there. So your median will be smaller than your range, okay, skewed right. Median, so X bar will be greater than the median. Skewed left, okay, this is a skewed left, all right. So your median will probably be somewhere up there, and your mean will be here. So in this case, X bar, the mean is less than the median. Okay. Now, some might ask, well, what about symmetric? So what if you had like a symmetric type graph? Okay. If you had a symmetric, X bar would be about the same as the median in a symmetric situation. The mean and the median would be very close together. So those are your three situations. Okay, here are the passing yardage totals for Pittsburgh Steelers quarterback Terry Bradshaw for each of his 15 games in the 1980 regular season, and there they are. First, they want us to sketch a dot plot to show Bradshaw's distribution of passing yards. So what I want to do is find the highest number of yards. So if I look here, that should be 299, and then his lowest, I think, was 100. Okay, so his minimum is 100, max 299. Sorry, I'm scribbling. So when we make our dot plot, okay, we can go in increments of 25, 150, 175, 200, 225, 250. Again, I'm sorry, I'm scribbling. 275. It's been a while since I've used the stylus, kids. 300. Okay, so now 254 puts us right about there. 282. So now we're just filling in the dots. 265, 217. Okay, and you guys can fill these in. 237, that's real close. 299 obviously is way up here. 135 way down here. Whoops. 100. 263. Let's see, that's right around there. These aren't great dots. The stylus doesn't make great dots. Sorry about that. 155, 289, 138. Whoops. Come on. 197, so it's real close to 200, and 272, which is real close to 275. Whoops, come on. All right, so there's your dot plot. Okay, values are spread out. All right, now it says calculate the mean and median of Bradshaw's distribution and label these values on the dot plot. So part B, okay, to find X bar, okay, to find X bar, we're going to add all of these numbers up. Okay? So the sum of his performances divided by the number of performances. Okay? So that's 3,339. I'll spare you the work. Okay? You guys can plug in your calculator if you want to. All right, you can divide those out and you get about 222.6. Okay? Now, the median, before you do anything else with the median, you've got to reorder the numbers from smallest to biggest. Okay? So, let's see, what do we have here? 100, 135, 138, 155, 197, 217, 236, 237, 254, 263. I need a wider iPad. 265, 272, 282, 289. Oops. 299. I think that's it. Yes. So let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 15 numbers. So the median is going to be the number right in the middle. Well, the number in the middle here is the 8th number. That means there's 7 numbers to the left, 7 numbers to the right. Okay? And that median is 237. Okay? So basically, the median, so in this case, X bar is less than the median. So if we were to do a distribution, it would probably be skewed to the left. Okay, remember, skewed means the lower bars are that direction. Okay? So that's what the issue is there. Okay, so here's your mean, here's your median. Okay? All right, so it says describe the, we don't have to describe the shape. We'll scratch that out. Describe the relationship that you would expect between the mean and median in the 4 histograms of NHL data in exercise 10. Okay? Well, the mean, so this is, which is this? This is skewed right. So that means that X bar is going to be greater than the median. All right? This is roughly symmetric. So X bar and the median are about the same. They're not exactly the same. They're about the same. Okay, so it's somewhere in there. Okay. Here, X bar is right about there. And again, we don't have exact numbers, so it's hard to say. Median's right there. Okay. C, if you were to say, I would say that's symmetric. Okay, again, I apologize for scribbling. So X bar and the medians, the mean and median, are again about the same. They're not exactly the same. They're close. They're real close. All right. And then the last one is skewed to the right, which means that the mean is greater than the median. Okay. So again, just come back to this right here, and that'll help you with those problems. Okay, suppose you're a high school running back and are hoping to get a college football scholarship. Suppose like you're Kareem Hunt and you were hoping to get a college football scholarship, even though he's like all world right now. Describe a situation where it would be better to report your median yards per game instead of your mean yards per game. Now the thing here is, remember, all right, a bad game affects your average greatly, okay? So, if you had a bad game or two, then you would use the median. Because remember, the median is all about where the number in the middle is. It's not necessarily about the values, it's about the number in the middle. The mean, the average, okay, any number, any big number, any small number could affect that average greatly. So like I said, if you average 147 yards rushing a game, and you have a game where you rush for 30 yards, that average is going to come down a lot. The median can kind of hide that, okay? The median can hide those smaller, bigger numbers because it's really all about the number in the middle. Okay, so that's 4.3. You guys should be able to do the rest of the problems on that for that section. Okay.